How to write a rational function with a hole at x equals 3, vertical asymptote at x equals -1, and an x-intercept at x equals 2. First, we must come up with a name for the function we are creating, so we will call it f of x. Determining a hole at x equals 3. When x equals 3, both the numerator and the denominator have to equal 0, so the graph would have a hole in it at this point. To write this out, it would look like this. F of x equals x minus 3 all over x minus 3. So these two cancel each other out when x equals 3, leaving a hole at x equals 3. Determining a vertical asymptote at x equals -1. A vertical asymptote is an asymptote that is parallel with the y-axis, which the curve will approach but never touch. Adding this to our function f of x, we will set the denominator to x plus 1 equals 0. Therefore, x equals -1, giving us a vertical asymptote. F of x equals x minus 3 all over x minus 3, x plus 1. Determining an x-intercept at x equals 2. When the numerator of a function is equal to 0 and x equals 2, we will have a point where the graph crosses this intercept. So to find the intercept, we must see what will give us x equals 2. X minus 1 equals 0, so x equals 2. Plugging this into the function f of x will look like this. F of x equals x minus 3, x minus 2, all over x minus 3, x plus 1. So the final rational function will be f of x equals x minus 3, x minus 2, all over x minus 3, x plus 1. At the function f of x, there's a hole at x equals 3, a vertical asymptote at x equals -1, and an x-intercept at x equals 2.